let's talk about analytic geometry. In analytic geometry, we will be talking about how to use the coordinates of any point given on the Cartesian plane to find out the distances and the position of other points related to them. So we'll be focusing our discussion today only on the distance formula. The distance formula describes the method how the distance between any two points on the coordinate grid can be found. We have discussed the distances on the number line when we are using the positive and the negative numbers on the number line, but how we'll be using and applying that concept on a Cartesian plane where there are two number lines, X and Y axis. Before we start discussing that, we have certain points to remember. The first thing that we have to remember is that the answer of a distance is always calculated by finding the position of any point on the coordinate grid. And to do so, we have to remember that every point is unique, the position of every point is unique, and two different points can never have the same position on the Cartesian plane. The second thing to keep in mind is that the distance is always positive. So irrespective of which coordinate or which axis the point is located at or in, the distance when calculated is always a positive distance, whether the values were negative or positive. We also have to make use of the Pythagoras theorem, as you must have learned in your previous grade. Taking a look at all these 3 points, how they will be helping us on calculating the distance formula, let's talk about a point that's named A, and or let's say there is a point which is described by a position 1, 2. How can we plot this point on the coordinate grid, or where can we plot this point on the coordinate grid rather? So I would say 1 is the X unit and 2 is the Y axis distance. So this is where my point is, and I name this point as A. Right? Now, if I say there was another point whose coordinates were -1, 2, and I want to name this point also A, is it possible? Let's see, because when I plot this point will have -1 units on the x-axis and 2 units on the y-axis. So this is here. The position of these 2 points are different. When 2 different points have different positions, I cannot use them as A. This is wrong. How I will use this is, I will be using this by a different name. And I can name this maybe a B. So 2 different points cannot have the same name if they have different positions. The second thing that we wanted to talk about is, if we are calculating the distance between any 2 points, wherever they might be, the distance is always positive. For example, you are at the origin and you take 2 units left. So if I ask you how many units did you travel or how many units did you cover in this first jump, the answer will not be -2. As you're going on the negative side, it will always be 2 units. If you take a 5 units jump on the right side, the distance is 5. But if you're going 5 units on the left, this is also a jump of 5 units. That's a different way of saying that I'm going 5 units on the left. That just describes that I'm going to the negative side of my x-axis, but the distance when I'm writing as an answer should never have a negative sign in the answer. Also, how we will be making use of the Pythagoras theorem, we will be talking through my next example. So let's see here. This is the distance formula that we are going to derive and apply for finding the distance between 2 given points. So the x's and y's represent the position of 2 different points and how we are going to use them. Let's take example here. So I'm plotting 2 points, A and B. So let me start from A here. and let's say there is a point B over here. So I name them and I name their coordinates as well. So A, and the position of A is 1, 4, and the position, this is my point B, and the position of point B is 4, 1. Oh, okay, fine. Now the distance between point A and B means if I join these 2 points using a line, what will be the length of this line segment? This is also another meaning of distance formula. So I'm calculating the distance between these 2 points. It also means I'm finding the length of the line segment joining points A and B. For doing this, I would find out the X and Y values for both these points. So let's start by saying that point A, whose coordinates are 1, 4, so I just write them here, 1, 4. These represent X1 and Y1, right? And the point B, whose coordinates are 4, 1, they represent the values of X2, Y2. That means the X coordinates and the Y coordinates for 2 different points. Now I'll try to find out X2 minus X1. What is that? So my X2 is 1 and my X1 is 4. So 1 minus 4. And that equals a -3 using integers. I do the same for my Y values. So I find out Y2 minus Y1. So my Y2 is a 1. Well, I think I changed the values of X here. So I would try to just fix it here, this thing. So I start with my X's again. So when I say X2 minus X1, it is equal to 4 minus 1. That equals a 3. Whereas my Y2 minus Y1 would now be 1 minus 4. That equals a -3. That's using integers again. Now, I square the differences X2 minus X1 and Y2 minus Y1. So when I find out the square of X, I make a 9. And when I find the square of -3, I make a 9 again, because negative times negative makes a positive. So now these 2 numbers that I have found by squaring the differences, X2, X1 and Y2, Y1, will be helping me in calculating the distance. So my next step will be adding these squares. So I add 9 with 9, that makes an 18. And when I find out the square root of 18, that will be my answer. So what's the square root of 18? Just a moment here. So the square root of 18 is approximately 4.24. Now this is the answer for my question, which tells me the distance between the 2 points A and B. Now, what is the use of Pythagoras theorem here? Let's try and check our answer using the Pythagoras theorem. So the Pythagoras theorem will help me only when I have a right triangle. So what I do is I draw perpendiculars from the 2 points A and point B here like this, and they meet at this point. And I have to name this point so I can complete the right triangle. So this point is a C. And if you notice, the coordinates of C are, the X coordinate is 1 and the Y coordinate is 1 again. The Pythagoras theorem helps me finding the missing parts of a right triangle only when I know some parts already. So over here in the triangle ABC, if I want to find out the length of AB, I must know the length of the perpendicular, that is AC, and the other side BC. So how much is the length of AC? That's the vertical distance. So distance between the 4 and the 1 on the number line on the Cartesian plane is 3 units. The distance between A and C is 3 units. So that's my vertical distance. Now, what is the distance between B and C? That's the horizontal distance again. So if I try to find out 4 minus 1, or where I started and where I ended, I get the distance of 3 units again. Now, if you remember how the Pythagoras theorem helps us, you will find out the square of 3, the other square of 3, and then you add them. So if you want, we can try them one more time. The square of first 3 was 9. The square of other 3 was 9 again. And when we added them, we got an 18, right? Now, what is the distance? Is the distance 18 units on AB? No, we know that we have to calculate the square root of 18, which we just did, and it came as to 4.24 units. So that's how we have verified how this formula using the analytic geometry and x and y coordinates is derived using the Pythagoras theorem. So this is all about how we can find out the distance of 2 points. So let me review. We find out the differences between the x units. We find out the differences between the y values, and then we square and add them. The final answer will be the square root of whatever I have got by adding. So this is the Cartesian plane and distance formula. Hope this has helped you. Stay smart.